Today we are going to learn factor theorem in this video, and for this we will be using our conceptual way of understanding things. Once we understand the things well, we will not have any problem understanding this, and then writing it, proving it will be easy for us. So let us begin to understand the concept behind it. First of all, we need to understand what is factor. We all know, but let us recall with a small example. How do we write 12? We write it as 4 into 3, and we call 4 and 3 as factors of 12. How do we write 15? We write it as 5 into 3, and we call 5 and 3 as factors of 15. So either we divide 12 by 3 or we divide 12 by 4. We get, when we divide 12 by 4, we get 3. When we divide 3 by 12, we get 4. And these two are factors. So this way we get the factors, and this is a small thing which we all know. I just recalled so that when we see factor, that thing comes into our mind, then it will be understandable for us. We have learnt in case of remainder theorem that we had been dividing polynomials. So here also it says like this only, that if px be any polynomial of degree greater than or equal to 1, then this says about factor. So this says that first condition is x minus a is a factor if PA is equal to 0. Then the second thing is the vice versa of it. PA is equal to 0 if x minus a is a factor. So in first case, x minus a is a factor if PA is equal to 0. PA is equal to 0 if x minus a is a factor. In remainder theorem also we have learned that x minus a we need to remember. So here also that x minus a is only being used, and we can always we can always write factor theorem as px is a polynomial in degree greater than or equal to 1, and we are if we are getting a factor x minus a, then PA is equal to 0, and if we are getting PA is equal to 0, then x minus a is a factor. These things we need to prove, because this is the factor theorem and we need to prove it. For first case, x minus a is a factor if PA is equal to 0. From remainder theorem, when we know that when we had been dividing px by x minus a, or let us again understand this, we are dividing 15 by 6, so we get equation like this. So in case of polynomials, when we are dividing px by x minus a, we are writing it like x minus a qx plus rx, a quotient polynomial and a remainder polynomial. From remainder theorem, we know that this remainder polynomial, in place of remainder polynomial, we know that in remainder theorem it says that the remainder would be PA. When we are dividing px by x minus a, the remainder would be PA. So in place of this Rx, we can put the value as PA from remainder theorem. From remainder theorem. Now, if PA is equal to 0, so PA is equal to 0, so in that case, what will be Px? Px is equal to x minus a into qx. When this Px can be expressed like this, x minus a into qx, then it is proved that x minus a is a factor. Because when here you see, if there is a non-zero remainder, then this 6 and 2 are not factors of it. But when we write 12 as 4 into 3, in that case the remainder is 0, and when this becomes 0, these two are factors of 12. So here when we are able to prove that Px is equal to x minus a into Qx, then x minus a is a factor. So first point is proved here. Now let us see the second part. Second part says Pa is equal to 0 if x minus a is a factor. If x minus a is a factor, then the polynomial Px can be expressed as first factor multiplied by a second factor. Since it is a polynomial, this is another polynomial. So with this we get Px is equal to x minus a into Gx if x minus a is a factor. Now put the value of x is equal to a in this, then we will be getting Pa. Pa is equal to a minus a into Gx. A minus a is 0, so Pa becomes 0, and we have proved that if x minus a is a factor, then Pa is equal to 0. This is proved. So this is quite simple, easy, and once we understand this concept, once we understand the things, it will be very easy for us to write and prove the theorem wherever we are asked to do it. So all the best.